So today in science, we're going to be talking about matter, we're going to be talking about volume, we're going to be talking about mass. So to start off, right here, it says that matter is any object or substance that has mass and it has volume. Mass is the amount of matter in something. Volume is how much space something takes up. So mass, generally people associate with weight. Weight is actually the gravitational pull of something towards the center of the earth. And that changes, right? Our weight can change. If I stopped eating cookies, my weight would change. I'd lose weight. If I ate a bunch of cookies, I would gain weight. Mass does not fluctuate. Mass is the amount of matter in something. So take this wrench, for example. This wrench has a constant mass. So mass is generally measured using something like a balance or a scale. We measure mass in units called grams. This is definitely lined up. So I want to know, we're going to measure the mass of our wrench. We're not measuring weight, we're measuring the amount of mass that's in here. I'm going to put my wrench on this side of my balance. And as you can see, it dipped down pretty far because I don't have anything over here to counterbalance it. We're going to use our little hexagram weights. You've got 5 gram weights, got 1 gram, got 10 gram, and you've got big old 20 grams. We're going to use these to figure out how many grams or how much mass our wrench has. So we're not finding the weight, finding the mass, how much matter is inside of our wrench. So let's just start right away with the 20. One of my 20s, it's not gonna get me it. I think we should go another 20. I saw it move a little bit. So 60 grams. Our wrench still has a greater mass than 60 grams, but try another 20. Ooh, you see what happened there? We got up to 60 grams. Our wrench still had a greater mass than 60 grams. Then I put in another 20 to make it 80 grams on this side. Well, now this side went down and this came up. So that means our wrench has a mass between 60 grams and 80 grams. So take this 20 out, right? Goes back down, let's put in a 10. It's going to be less than 70 grams because this side went down. We're back to 60 grams. Let's try a 5 gram. So our wrench, as we can see, is less than 65 grams. We're gonna take that out. And let's just keep going down. We know that it still has more mass than 60 grams, right? There's 3 20s in here. So now we're going to take our 1 gram hexagons. We're gonna put 4 of them in there. It's less than 64. Now we have 63 in there. I took out that last chip from 64 grams, we went down to 63 grams. Our wrench is almost exactly perfectly balanced at 63 grams. That means the mass of our wrench is going to be 63 grams. So we talked about mass. Our second part, volume. When we're talking about volume, right? When we're talking about volume, we measure volume in milliliters. The definition for volume is the amount of space something takes up. So we're not measuring the mass of it, we're trying to figure out how much space that object takes up. When we're looking at volume, we are looking at measuring it using things like a graduated cylinder, we could use a beaker, we could use even a mason jar, as long as it has the measurement of milliliters. You take a look. Right there, it has the measurement of milliliters. Whenever we're measuring this off, just like with our scale, we want to be as precise as possible. Let's figure out how many milliliters of water we have currently in our graduated cylinder so we can see exactly where the water level lines up on our graduated cylinder. This one's measured in increments of 5 milliliters at a time, but luckily for us, it's right on that 200 dot. How can we find the volume of this if we're measuring in milliliters? So right here, we can tell that the volume of this water is 200 milliliters, right? Very easy to see that. Especially with liquids, it's very easy to find the volume of that. But when we're finding the volume of something like a wrench, something that's solid, that doesn't look like, I can't tell it's as tall as the beaker, but that's not gonna help me figure out how many milliliters of volume our wrench takes up. we're going to actually use our graduated cylinder and our 200 milliliters of water to figure out how many milliliters of volume, golf ball keeps going around, how many milliliters of volume this wrench takes up. I have 200 milliliters to start off with inside of my graduated cylinder. I want to find the volume of my wrench. We're going to use liquid to help us find it. I'm going to put this wrench inside of my graduated cylinder. When I did that, we started off with 200 milliliters, and if I pull it closer, we're definitely above 200 milliliters. We start off with 200, just the water. Now we have the water and the wrench in there, which got up to 205 milliliters. So we started at 200, went up to 205. So what we're gonna do with those two numbers, we're gonna take the water plus the wrench, 205 milliliters. Then we're gonna have just the water, which is 200 milliliters. We're going to subtract those values, and we're left with 5 milliliters. The volume of our wrench, or how much space our wrench takes up, is going to be 5 milliliters. That is how you find the volume in a solid. You guys get a bonus clip because I almost forgot about this. This is very important. Volume, especially when it comes to liquids, does not change whenever you're pouring it from one container to another. Okay, right here I have the exact same amount of volume. I've got 200 milliliters in this hand, I've got 200 milliliters in this hand, 200 milliliters of water. When you look at these two things, right? This looks really, really full. It looks very full. This one, not so much. Because of the shape of the container, it looks like this graduated cylinder has a lot more water in it, more milliliters, than our beaker over here does. Both of these still have the exact same amount of water. 200 milliliters are in both of these containers. Our graduated cylinder has 200 and our beaker has 200. Even though it looks like we have more in this container than this container, that's not true. We have the exact same amount of milliliters in both containers. So I hope this definitely helped you guys out. I know I had fun making it, and we'll get back to class.